Hi guys, let's take a look at this question where they gave us two blocks, A and B. They tell us that block A is 4 kgs and block B is 9 kgs, and they're connected by this light inextensible string. When we think of string, anything that's connected with string or whatever the case may be, we're going to think of tension, right? And the blocks are held at rest on a plane which is inclined at an angle of 35 with the horizontal. Then we also have the constant force here acting parallel. So we're going to have force parallel to the plane, and it's only applied to block B, but not really because remember they are attached by string, and the blocks accelerate at 2 meters per second. 2.1. State Newton's second law of motion. Guys, please, out of your heads, you have to know this. Newton's second law says that when a net force acts on an object, the object will accelerate in the direction of the force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Then they tell us that the kinetic frictional forces of block A is 5,88 and the kinetic frictional force of block B is 13,23. They want us to draw a free body diagram showing all the forces on block A. So on this block here. So this represents the block. Okay, so do we see we have weight, we have tension, we have friction, and we have the normal force. So we draw weight. Normal force is a bit longer than weight. Then we have tension, and then because of the string, and then we have friction, which is shorter than tension. And that will give you 4 marks because it's 4 forces. 2.3. Calculate 2.3.1 the tension in the string. Okay, so what do we have to use? We're going to have to use block A because we have the tension that we're going to have to calculate. We have the friction and we have the parallel force. We can't use block B because two of the horizontal forces are unknown. That will be the tension and that constant force. So we can't use block B. So we will have to use or look at block A. All right, I'm taking up the incline as positive. So I'm taking my horizontal forces. The sum of my horizontal forces. So it's going to be my tension minus my friction, and then there's also the force acting parallel to the plane. So F parallel. Okay, so F parallel is going to be mg sin theta. So we have our frictional force, which is 5,88 that was given. That's a negative or minus. The mass is 4, the gravitational force is constant, and it's going to be sin 35 or sine 35 degrees. And then the mass is 4 and the acceleration is 2. They've given it to us there, 2. So we do our math magic. We multiply, we take over to get T on its own. So the tension in the string is going to be 36,36 newtons. Okay, then the next question, 2.3.2. Calculate the force F. So they want us to calculate the magnitude of that force. So we will have to use block B now, right? Because it is acting on that block. So we will have to then calculate the horizontal forces because that's the only way we can find that missing F. So my horizontal forces will be my missing F minus my tension. Remember, there's still a string there. Minus my frictional force. And don't forget your parallel force. So I'm just going to write it out one more time just to show you. I don't know why I keep making an equal sign. That's so silly of me. It's a minus. All right. And it's going to be mg sine theta. So F is going to be unknown. We have just calculated the tension in the string to be 36,36. They've given us the friction of acting on block B, which is 13,23. Our mass of block B is 9. Gravitational force is 9.8. That's going to be sine 35 degrees again. And the mass is 9 and the acceleration here is going to be -2. Why? Because we took up as positive. Then I'm going to do my math magic. I'm going to multiply. I'm going to take it over. And I'm going to get my force to be 118,18 newtons. Remember that acceleration will now be -2 there, guys. Just want to reiterate that. But that is it. Our force is going to be 118,18 newtons. Okay. Now the angle of this plane is decreased. So now it's not anymore 35. It's like decreased to there or wherever the case might be. It's just decreased. 2.4.1. How will this change the kinetic frictional force acting on block A? Choose increase, decrease, or remain the same. It will increase. Why? Because frictional force is directly proportional to the normal force. So essentially what I'm saying is that, remember, we have frictional force. We have a coefficient of friction, right? If coefficient of friction and mass is constant, if the angle of that plane decreases, the normal force will increase. All right? The normal force will increase. And because frictional force is directly proportional to normal force, frictional force will also increase. So friction is directly proportional to normal force, and that is why frictional force will also increase. All right, guys. And that is it. See ya.